General relativity requires that the universe originated from a singularity, a single point of infinite density. However, quantum mechanics dictates that an infinitely dense, perfectly compressed point is a physical impossibility due to the uncertainty principle. This is a page from Alan Guth's 1981 paper outlining the inflationary universe. The equations successfully explain why the cosmos appears flat and uniform on large scales, but the model still requires the timeline to trace back to that impossible point of infinite density. Theoretical physicists recognized early on that the model was incomplete. The initial mathematics suffered from what Guth called an ungraceful exit, failing to explain how the rapid expansion could smoothly transition into the universe we observe without breaking down. The mathematical failure at the singularity does not prove the universe began from nothing. It simply marks the exact coordinate where our current laws of gravity collapse and cease to function. The cosmic microwave background is the absolute oldest light we can observe. Standard inflationary models predicted this radiation field would be perfectly uniform, displaying the exact same temperature profile in every direction. This map shows the cosmic microwave background's temperature fluctuations. Scans revealed large-scale deviations from expected uniformity, a measurable energy deficit, a stark temperature difference between hemispheres, known as a dipolar asymmetry, and a distinct geometric preference for odd parity multiples. The scientific community initially dismissed these asymmetries. The uneven signatures were widely classified as random statistical noise, cosmic variance, or minor instrument errors. A new generation of theoretical physicists takes a different position. They identify these anomalies as physical imprints, fossilized structures that survived the destruction of a universe that existed prior to our Big Bang. Superstring cosmology approaches the origin of the universe by discarding the concept of absolute nothingness entirely. The theory utilizes a mechanism called scale factor duality. As a universe collapses and compresses down to the extreme limits of the Planck scale, it strikes a physical geometric boundary and mathematically inverts into an expanding state. This creates a physical bridge. Rather than an explosive birth from zero, the universe rebounds, allowing structural information to survive the extreme compression and transfer into the new expansion phase. Loop quantum cosmology attacks the singularity by redefining space itself. The framework treats space-time not as a smooth, continuous fabric, but as a structure woven from discrete atomic geometry. When a collapsing universe condenses to a density of 10 to the 94th grams per cubic centimeter, this atomic geometry triggers a threshold. At that specific density, quantum physics forces gravity to switch polarities and become immensely repulsive. The extreme physics of this pre-inflationary bounce generates strong correlations between the largest observable waves in our sky and super-horizon wavelengths that exist beyond our visual limit. Physicists call this non-Gaussian modulation. This non-Gaussian modulation physically skews the temperature distribution of the early universe. It cleanly produces the exact dipolar asymmetry and odd parity geometric signatures that the Planck satellite mapped. Loop quantum cosmology removes the infinite point of the Big Bang, replacing it with a mathematically rigorous bounce that directly explains the most persistent anomalies in the night sky. Nobel laureate Roger Penrose developed an alternative mathematical framework that bypasses the need for a violent physical bounce. In his model, known as Conformal Cyclic Cosmology, our universe is a single link, an eon, in an infinite sequence of cosmic lifetimes. At the end of an eon, the cold, infinitely expanded cosmos loses physical scale. Through a conformal crossover, it scales down mathematically, becoming structurally identical to the highly compressed, hot conditions of a Big Bang. A transitional era dominated by gravitational waves smooths out the severe geometry, seamlessly stitching the dead, empty expanse of the prior eon to the explosive birth of the next. This transition leaves a specific fingerprint. The final Hawking evaporation of supermassive black holes from the previous eon should imprint localized concentric thermal ripples in our cosmic background, structures Penrose refers to as Hawking points. If observatories can conclusively isolate these temperature spikes, they provide testable, observational evidence that our reality is embedded in an endless chain of universes. String theory, loop quantum cosmology, and conformal cyclic cosmology operate on entirely different mechanical principles, yet their mathematics arrive at a shared conclusion. The universe did not materialize from nothing. The cosmic microwave background has now transformed from an initially opaque boundary into an active, transparent record of cosmic expansion. The anomalies mapped across its surface, the asymmetric temperatures, the suppressed power scales, the gravitational ripples, turn that background radiation into a translucent lens, offering a direct view into the physics of the cosmos that preceded us. These models suggest a timeline where the Big Bang was a transition rather than a beginning. We are exploring the possibility of an infinite cosmic cycle, where our universe is built upon the structural remains of those that came before.